Hello everyone. In this particular video, we will be looking at this transformer. It is a Tesla transformer limited 630 kVA transformer. So in this particular video, we will be looking at the nameplate of this transformer. We will be one by one in detail. We will discuss about the meanings of the parameters written in the nameplate. So we will go to the nameplate. So as you can see, there is written transformer conventional type. Conventional type in the sense that it is the type of cooling that we use is natural, air natural, oil natural, or we say onan, right? So you see there the temperature rise of oil allowed is 50 degrees Celsius over an ambient temperature of 50 degrees Celsius. So if you combine both, you will get 100 degrees Celsius. That means the moment the temperature is up to 100 degrees Celsius, it is fine. The moment it crosses this, then your NO's contact of the temperature of the winding temperature oil temperature indicator will actually give you trip command. So this and then for the winding, if you see, it is 55 degrees Celsius. So 55 plus 50 will be 105. The moment the temperature of the winding rises beyond 105, the NO's contact of the winding temperature indicator will short and then finally trip the breaker to isolate the breaker, the transformer in fact. And you see there the voltage of the high voltage winding voltage is 33,000 volt, and your LV voltage is 433 volt. This is measurement is at no load. And then the current also, because since it is a step down transformers, your high voltage winding, it's of higher voltage, that means your current will obviously go down. So your low voltage current will be 11.02, and your low voltage current is 840.02. And then, as I said, the type of cooling is onan, and then the rated frequency is 50 hertz, and that is the grid frequency in India. And as you can see there, the vector diagram also have been given. I will just a little bit about the vector diagram. There is written Dyn1. Your capital D indicates that it is in the high voltage connection is in delta. I mean a three-phase 3-wire delta connection, and your secondary is Y, that is it is in Y connection with neutral, and 1 there it indicates 1 o'clock. See there, 2U is 1 o'clock. That means your secondary voltage is actually lagging the primary voltage by an angle of 30 degree. Okay, so you see sometime it is written as dy11 also. That means your secondary voltage leads the primary voltage by an angle of 30 degree, but in this particular case it is lagging by 30 degree. All right, so the company's name is Tesla Transformers Limited, as I said. So it is manufactured in Bhopal, which is in the state of Uttar Pradesh in India. So, and then we will just be moving a little bit up just to see a bit more details about this transformers, because this is the transformers that will be installed actually in big buildings, as you can say that like your hospital, your hotels, big hotels like your 5-star hotels, they will keep these type of transformers. You see there is the kVA rating 630 kVA. This is a standard rating actually, and the serial number TTL means the Tesla Transformer Limited, and it was manufactured in 2009, and the vector group, as I said, is Dyn1, and then the impedance voltage is 5%. That means that if 5% of 33,000 volt will be how much? 5% of this will be around say 20,000. No, it is around 1,000, right? If 1,000 volt is being if you apply to the primary voltage, and you will get a secondary current circulating in the secondary winding, and then the weight of oil have been given to be 700 gram, oil quantity 815, tank and fitting 650, and the total weight of this is around 2.7 tons. And this is what your the phasor diagram, the vector diagram also I have already discussed, and this is the connection. The winding have been given like this, as you can see, I mean, there is no physical connection between the high voltage and the low voltage windings. It's written there 1U means your high voltage winding and 2U is a secondary uh, winding. Sometimes you will see 3 also in some case. That means it is you have tertiary winding also in that case. So this is what you see about this transformer. When you discuss about this is a distribution transformer, all right. Sometimes the efficient or the losses also have been given, but in this particular no losses have been provided, because normally you would see that in distribution transformers. But since this is not actually installed in villages, except that if it is a big village of say 300 to 400 households, then you need to install this set of transformers. So thank you, this much only.